All right, so we're gonna look back at similar triangles a little bit more today. We have this, now we're talking about the idea of theorems that we have to be able to identify first, right? So we're backtracking the similar triangles a little bit and then try a little bit trickier ones, right? So it's a good little review for us. So here's an example of question that's slightly trickier, not really a ton trickier, but we'll go through it. So notice here that you're not given the information, right? So first we have to like guarantee similarity. So first, do we have similar triangles? Right? People sort of overlooking that because up until now, of course, we were just given similar triangles, do this and use it to find information, right? Looking for side DE here, but we're not told that there's any similar triangles, right? But we are told that they have parallel lines. And so you could, based on that, call this, say, angle A, call this angle B, or maybe I should just call it A instead and be like angle A equals angle A. And the reason we know those are the same is because of parallel lines theorem, and it's the Z pattern. If you a quick refresher on that, I can show like this. Oh, not Z patterns, F pattern. When I go to do this work here, I can easily correct that for myself here, right? So you've got those two angles are the same because they're corresponding angles based on the F pattern. Okay, so fix that for us. So let's get rid of the highlighted version so before this diagram gets too messy. And then by the same logic, we have angle B, but angle B is just sort of an upside or backwards version of it. They're both kind of upside down. So angle B is angle B. Angle B equals angle B. Parallel lines theorem, F pattern as well. And so that means we have the triangles are similar. So triangle, we could say ABC is similar to, in the same order here, so I'm going to go A, B, C like that, and then A, B, E. Okay. So because those are similar, I'm going to move that out of the way so the diagram doesn't stay messy here. So based on that, we know we got ratios of sides that are equal, right? And so we could do side of the triangle over the base, or we're looking for that base, right? So let's start with that base like we like to do. So start with DE that we're looking for. We could say the ratio over the left side. So the left side's a 5. That will equal the base of the bigger triangle over the left side. Notice the left side is both of them combined. So I might write that as the 18 over the 10 plus the 5. I think it's communicated fairly well there, why and what happens and so on, right? And so we have that. And so I can just multiply both sides by 5. Too many colors going on here. Multiply both sides by 5. And I'll just show we end up with the 18 times the 5, which as opposed to 5 times 10, 40, 50, and 40 is going to be 90, right? But so we got the 90, double check the calculators to make sure, divided by 15, and I'm not going to bother doing that one. I'll just divide it out. So 90 divided by 15 is 6. That would have been doable too. I suppose 15 was in 30 twice, so into 90. Yeah, 3 times twice, so 6. So DE equals 6. That's the side length, and we're done. Okay, but it involved determining or proving similarity first, and then using it. Okay. And another one. Press pause if you want to try it and be an active learner and see if you can do it. Give yourself some room here. Yeah. So hopefully you're maybe gave it a try there, and you're going to look at it and see how you did. For this one, what do we have for information here? So actually we have parallel lines again, so we could do the same exact same as last time, but just to mix it up a little, I'm going to say angle O equals angle O. So let's say similar triangles, question mark, we've got angle O equals angle O. That's because of their opposite angles. might have seen that as OAT, opposite angle theorem. And angle, we could label this one as like angle A if we want. This one over here is angle A, and that is the Z pattern this time. So angle A equal to angle A, parallel lines theorem, Z pattern. And I'll show it the same way as before here. We have a Z pattern. That means that angle and that angle are the same. And it's just something that's true for as a property based on parallel lines and lines across them and so on. So once again, we have triangles. We have similar triangles by a angle similarity. Did I finish that last time? Did. So this is that triangle, and it's by angle. That's one way you can do it there too, and or just angle similarity here. Okay, so we have angle similarity again. So angle similarity. So we have triangle. What do we have? Let's start in the middle, and then go to A and around to the other one. So I guess if I'm going to label this, I should put some numbers on. So let's call this A, B, and C. So, and that's totally doable. You can do that yourself too in your work. To be able to communicate, right? When you're doing the solution, just label them. They aren't already labeled. So A, B, C. And then I'm going to start again at the point, and I'm going to go to angle A and over, right? So angle A and around again. And so I'm going to label A, B, C, B, and E, I guess, right? So A, D, E. So there's my similarity going on. And then so that you could look and say, well, the AE is for communication here. The A side is the AD side, right? A that we're looking for is the AD. And so AD is the first thing we went through. So AD is similar to the AB, and that actually lines up like that too in the labeling, right? So you can say it's can be in ratio with that one. So we could do the A side over the 7.5. I might just redraw this in a second to help communicate it as well. It's a bit confusing to go if they're not in order. So let's do that right now, actually, to make it easier to follow. We don't see too much here. So A is that center. We know we've got ABC and we want to do ADE. So ADE. And now I can carefully relabel. My AD side is 2. My DE side is 3. And everything else is yeah. And the AD side is the A that we're looking for. So it's just going to be a little easier if we just a little easier to picture what we're doing, right? Redrawing process. Go to my pen, purple here. So if we did, this over 7.5, then if we have another pair of sides that we know, so I grabbed this question off of just like a Google image and was thinking it was good enough, but we're missing a little bit of info actually, aren't we? Just looking to see if it's possible to do this one. Over 7.5. And 2 would correspond to the B. If we did A over 3, that would be, we need one more side. So I'm going to modify this question for next time I use it. So we have to pinpoint some kind of direct relationship, right? So let's say, I think I can do this. Yeah, just because the triangle's the way they are. Basically, we need a number here for this one. And there's no reason to have it anchored down to any particular multiple, because 2 multiplied by something would be that. A, an unknown, multiplied by something would be that. And then 3 multiplies by something would be this. And so as long as they're the same multiples, then we'll be able to find everything else. So let's just go with this being, say, I don't know, times, I want it to be longer than 7.5. So let's go by 3. That'd be 9. I guess I should have given the 9 in the question. I just didn't realize that until I was going through it. but that would give us an A over 7.5 and a 3 over a 9. Sorry for that confusion there. Get through it though. So 7.5, 7.5, and the size, that gives us A equals the 3 times 7.5 divided by 9. It's 2.5. Just writing the numbers on the calculator. So the A is that. And let's see if we can get the B side as well. So the B side, we need to do a ratio to do it. And so what's standing out to me right now would be, unintended here, the B over the 9 and the 2 over the 3. Yeah. Okay. So B over 9, 2 over 3. So multiplying both sides by 9 this time. And I can do this one easily because 3 divides into 9 3 times, 2 times 3 is 6. B equals 6. So that should be values. Okay. So determine as required here. These ones I believe have enough information in each one. They're just a little trickier in their the way they're tricky is, you know, like triangles within triangles. And so again, you want to be careful, like notice what you have. You have an angle that's the same as that one, right? And then the one that's hard to recognize here is that you have shared angle, right? So call this, maybe I shouldn't call it A, because we have A's and other things, but let's just call it like a little O or something like that, O and O. And then, you know, put a little star here. That angle A is shared between two triangles. And so you should be able to pick out A, first of all, like you're going to say angle similarity. And then you got to get the order correct, maybe redraw them, make it easier to set up your ratios, and solve for missing pieces. And each one has its own little bit of a challenge in this part of the homework practice assignment. So get those worked on and submitted. And maybe a little bit of a longer term challenge, but this one can be solved 3 different ways. So I'd like you to try this one and see what you come up with for a solution for it. And I'll later on be showing the solution, but I want to see what you try as an attempt first. So this one I'm expecting to be submitted, you know, as daily homework. This one, let's say, you know, maybe have a few days, like a week, like mid next week. That'll get a try and an attempt at least get submitted. Just submit whatever you manage to try and work on. I knew that there is 3 separate solutions that I've done for it, but are all very different from one another. So it's be a neat one to eventually take up, but you gotta try it first, right? So save that file and we're done. This one.